All right, welcome back everyone. Last time, remember we learned about latitude and longitude and time zones. But the latitude and longitude we learned about was mostly just to the degree level of precision. But in New York State, we can get a little more accurate than that. And in this course, you're going to have to be able to learn to read latitude and longitude to a more precise level, to the degrees and minutes level. All right, and there is a page in your reference tables with the New York State map. We're going to be familiar with that. You might want to get that out now just to have it there. So what do we know already? We know latitude lines go east to west, but they measure north or south. They measure north or south. How far north of the equator, how far south of the equator. That's latitude lines. Okay, we know longitude lines run north-south. They run this way, but they don't measure that way. They measure how far you are either east or west of the prime meridian. Places on Earth have an address. You can think of it that way. You have an address where you live, and you can find any address on Earth with latitude and longitude. There's 4 quadrants that you can think about the Earth as being located in. The northwest quadrant, which is above and to the left of the prime meridian and the equator. The northeast quadrant, which is above the equator and to the east of the prime meridian, above and to the east. The southeast part of the world, which is of course below the equator and to the east of the prime meridian, and the southwest part of the world, which is below the equator and to the west of the prime meridian. So that's like a general type of an address. And then we can add numbers to these places to get more details. In locating much smaller areas, such as where we live, or lakes, mountains, cities, it's necessary to use a more specific, more detailed coordinate system. By looking at a smaller scale map, like the one in the reference tables, we can see how more specific forms of latitude and longitude can be useful. See, in this map, you can see North America, but New York State is just this little tiny thing. So you really can't get too detailed. We need to blow this map up, zoom in. This is where page 3 of your reference tables comes in real handy. So you want to get that out. So this map shows New York State. It shows cities on New York State. It shows these funny shaded areas, which are the geological periods and eras in New York, and the rock types for each area. It also has in it a scale with distance. It mentions whether the rocks are sedimentary or metamorphic. It tells you the names of the rocks. And over here it tells you the geologic periods that the rocks were originally formed in. Now we'll learn more about those periods in Unit 5, but for now, let's keep it easy. Let's see, some information here that you might want to remember. Vermont's over here, Canada's over here, Pennsylvania is down south of us, Connecticut and Massachusetts are below Vermont, and this is the ocean, Long Island Sound, and the Atlantic Ocean's down here. Good things to know. Many of us are still geographically challenged. It's always good to review this stuff. Okay, so there's a line of latitude. That's 41 degrees north, 42 degrees north, 43 degrees north, 44 degrees north, and way up at the border of New York State and Canada, 45 degrees north. Longitude lines, 73 north or west, 74 west, 75 west, 76, 77, 78, 79. And that's as far up as we go. We don't go to 80. That would be in, Ohio somewhere. Seems like a nice grid. Now let's just go back to this grid just for a second. And you notice that the longitude lines do something funny that the latitude lines don't do. If you look carefully, you'll notice they actually look like they're leaning in towards the top a little bit. They get smaller towards the top. Remember, latitude lines are parallel to each other, parallels of latitude. Longitude lines meet at the North Pole. So they get smaller and smaller distance from each other as you approach the poles. All right, let's get more specific, like this box right here. So here's a zoom in of that box. And we'll see 43 degrees and 42 degrees north latitude. Those are lines going horizontally. And they do increase as you go up. 42 is lower than 43, so the numbers are increasing as you go up. But you can clearly see that there are increments on the side of the map, and the increments are marked in degrees. And these are north of the equator. This is a 1 degree difference, but let's pretend to break it down more precisely. In latitude and longitude, we have invented little marks between this called minutes. And there are 60 minutes, nothing to do with time here, 60 minutes of latitude between 42 and 43 degrees. So we can spread this into 60 imaginary minutes. Just like 1 hour, 1 degree has 60 minutes in it. The mark that separates the 1 degree spread is half. That's 30 minutes. And it is written like this: 42 degrees, 30, which is half of 60, halfway up right there. There's your 30 right there. Minutes. Has a sign that looks like an apostrophe. And you would say 42 degrees, 30 minutes north. Think of 1 hour as 1 degree, 30 minutes would be halfway. Now I like to kind of separate it out into halves of halves. Half of 30 would be about here, and it's 15 minutes. Half of 30 to the next one, where the imaginary 60 minutes would be, is 45. So it would just jump up. 0, 15, 30 minutes, 45 minutes, and then 60 minutes. Remember, 60 minutes would be equal to 1 degree. So we don't write 60 minutes there, up here. We write the next degree, 43 degrees and 0 minutes, or 00 minutes is the way we usually do it. Once again, the whole point is to be able to locate the address of places more precisely than just with degrees. You could even get more precise than that. All right, in fact, we're going to be getting down to about 5 minutes level of precision by the time we're done with all this stuff. This makes finding a location in something like a state much easier and more accurate. It creates a grid just like latitude and longitude lines, but a much smaller grid. And you can see how there's an X here, and that X you could actually locate because you have these zoomed in grids of latitude and longitude. Now longitude works the same way as latitude. It just runs left and right. Reminder, the lines that measure how far up or down are lines of latitude, and they're recorded north or south. This gets recorded first. I've already went over this the other day. The lines that measure how far left or right are longitude, and they go east or west, and they are recorded second. There's a comma put between there. Let's find one together. Location of Ithaca, New York. So on your reference tables, you'll find Ithaca is right at the south end of one of the Finger Lakes there. There it is. Now we always do latitude first, so the left and right line is latitude. There it is. Okay, you guys take a moment, estimate that. You'll notice it's not quite 42 degrees, 30 minutes. It's a little bit less than that. And the longitude, it's somewhere between 76 and 77. You guys do your best. Write it down in your notebooks. And then we'll go over this after the lesson's over. Okay, moving on.